Hey everyone, so here is our lecture video for section 6.4, which is all about nth roots. So we're going to talk about like square roots, cube roots, and all that kind of stuff. So this first part is going to be a little bit of review because we have talked about simplifying square roots before. So for that review, just a reminder, for simplifying radicals or square roots, you finding the square root of a number and squaring a number are inverse operations. And this inverse part is why they fit into our chapter right here. So that's why we're kind of going over them again. And what I mean by that is, all I mean by the inverse is that we know that 4 squared equals 16 and the square root of 16 equals 4. And just because it works like that, they're inverses. So then to simplify the following, you might have heard me say, let's put these in simplest radical form. And this is where we talked about, okay, what's the biggest square root? What's the biggest perfect square that goes into 18 evenly? Hopefully you guys would say, oh, 9 is a perfect square and it goes into 18 evenly. So we know that 18 is 9 times 2. Just kind of rewriting it there is 9 times 2. Well, thinking of square roots here, the square root of 9 is going to be 3. And then the square root of 2 is not a nice number. It's an irrational number, so we're just going to leave that in the square root. And that would be simplest radical form for the square root of 18. Before, we might have looked at it, just coming back up here, we might have looked at it as, oh, well, 9 is 3 squared times 2. And since the square root and the square cancel each other out, I pull the 3 out in front, leave the 2 behind. That's kind of another way we talked about it in class earlier in the year. And one more method you might have learned in the past, this one takes a little bit longer, but it's a little bit easier to think about, is you can break down what's underneath the square root sign to its prime factors. So I like to think of that as making a little factor tree like we did back in grade school. And I always just divide by 2 until I can't anymore. So 12 divided by 2 is 6. So I have 2 times 6, and I circle my prime factors because I know that I can't divide it by anything else. And then 6 divided by 2 is 3. And both of those are prime factors. So I could rewrite this 12 as 2 times 2 times 3. And then when we're doing this, we want to look for pairs underneath the square root. And we have a pair of 2's right here. So this is just kind of like 2 squared times 3. And then we're back to what we had in the last problem for the 18. That's okay, well the square root and this square right here cancel each other out. So it's just 2. And then I have my radical 3 over here left behind. And that's kind of our review of just simplifying square roots. Those tend to be the most basic type of simplifying radicals. And today we're going to jump in to having a root bigger than a square root. So that n, we're going to talk about solving nth roots, where n is just used to generalize any number. So we could talk about cube roots, fourth roots, and all of this kind of stuff. And then here's just some examples. So if we wanted to find the cubed root of 64, well, we know that 4 times 4 times 4 equals 64, which means the cubed root of 64 is 4. Same here, we got 5 times 5 times 5 times 5 is 625. So 5 is the fourth root of 625 because there are 4 of them. And that's just kind of a little example chart going through different examples. And the pattern we see here is what gives us this formal definition that we got right here. For any real numbers, a and b, and any positive integer n, if a to the n equals b, then a is the nth root of b, because they're inverses, so those exponents and those roots work together. So a little example there, negative 3 to the 4th is 81, so negative 3 is a 4th root of 81, and 3 is the principal root. We'll get to this part here in a little bit, so don't worry about that right now. And then just a little vocab here before we kind of jump in to some different stuff. The index is what we refer to as, in this case, the n, it's the number outside. You can think of it as the number in the little check mark of the square root, right? The little check mark, the number inside there. The radical sign is obviously what we're used to seeing, the square root sign. In this case, we're going to be working with not just square roots, but still just that little check mark looking thing. And then the radicand is what's under the square root. The radicand is what is under the radical sign, under the square root, under that little check mark. So that's just some vocab. So like if you're doing homework problems or a quiz question in the future and they say, what's the radicand? You would just have to point out the 81 in this case. So then moving on, now we're going to touch on what does that principal root mean. And just a little reminder here, some numbers have more than one real nth root. So example, we know 64, well, the square root of 64 is 8, but it's also negative 8, right? We know that 8 squared is 64 and negative 8 squared is 64. So when there is more than one real root and n is even, the non-negative root is called the principal root. So we can think of this as the positive root is the principal root. Since they both start with P, positive root is principal root. And so then just kind of breaking that down into examples of how we could see this. Say we're just given the square root of 25 equals 5. We're talking about the principal root because we're only talking about the positive 5. Say the negative sign's out in front. They want us to talk about the negative root. So we're doing the opposite of the principal root because it's negative. And then last but not least, we've seen this plus or minus sign a lot. That's just when we're talking about both options. So we've done this a lot already. We're just kind of putting a name to it. Doesn't affect how we do the math. Our process, solving process is the same, but it's just a little bit more vocab. So then before we jump into examples here, we have a little bit more on real nth roots. Remember, real numbers. And we suppose n is an integer greater than 1. So with a number inside that little check mark, our index is greater than 1. So 1, 2, 3, 4, 5. And a is a real number. And a is just going to be our radicand. All right, the number underneath the radical. If a is greater than 0, so that number underneath the square root is greater than 0, we have one unique positive and one unique negative real root. So that's when we're going to have that plus or minus there. When n is even, so 2, 4, 6. When n is odd, so 3, 5, 7, we have one unique positive and 0 negative. So when we have an odd index, we only have to worry about the positive root when a is greater than 1. So when underneath the root is positive. When underneath the root is negative, we're going to have 0 real roots because we know if it's negative underneath that root, we have imaginary answers, right? Remember that little I? Hasn't gone away, keeps coming back. And then when n is odd, so that's like square root, fourth root. When n is odd, so cubed root, we have 0 positive and 1 negative real root. And we'll get into that later in examples. And last but not least, when a equals 0, so what's underneath the square root is actually 0. We have one real root, and it's 0 when n is even, and when n is odd, it's also 0. So the square root of anything is 0, cubed root of 0, 0, fourth root of 0, 0, and so on and so forth. So we're just going to kind of use this layout here. We can kind of use this chart to guide us a little bit, and let's just work through some examples. So these look a little scarier than what we did at the very beginning of the lesson, but they really aren't too bad. The plus or minus is there because they tell us they want us to include a plus or minus in the end if we're looking at this guy right here. And if there's not a number inside this little check mark, we always assume it's a 2. It's always a square root. It's what we're used to seeing. They'll tell us if the index is anything but 2. So if we're looking at this 16y to the 4th here, we want to think in pairs. It's easy for the numbers, but sometimes when we get these variables in here, it gets a little messier. So if we're thinking about this, well, we know 16 is just 4 squared. And then y to the fourth, we want to break this down into pairs. Since we're taking the square root, we want to think in groups of 2, right? Square root groups of 2. Well, I have 2 groups of 2 for that y to the fourth, right? Because we can add these exponents to get 4. Or I can think about it, okay, 4 divided by 2 is 2, so I have 2y squareds. So then when I'm simplifying this now, well, the square root of 4 squared is just 4. They cancel. And then the square root of y squared is just y. And then the square root of y squared again is also just y. And whenever we pull more than one thing out of the square root, we always think multiply. So then this just becomes 4y squared. And then since they added that plus or minus at the beginning, let's go ahead and include that plus or minus at the end. And there's our answer. We found the root. We simplified it. We found the root. And that was one way to think about it. Once you start getting better at these, you could think, okay, this y to the fourth right here, well, 4 divided by 2 is 2. So I'm going to end up having 2 y's out in front. Since I had 2 y squareds here, I'm going to have 2 y's out in front over here. And we just show that using the exponent. So let's try part B over here on our own. Not on our own, we'll do it together, and then I'll have you guys try some on your own. They have the negative out here for us. So we'll just include the negative at the end. No big deal. We can ignore that until the end. And now we have this expression here raised to this 8 exponent. And again, no number inside our radical sign. We assume it's a 2, so we're still thinking in pairs. So I'm thinking, okay, I want to divide 8 by 2. Since it's a 2 out in front, I want to divide this exponent by 2, and I'm just going to leave it as that expression. I'm not touching those parentheses. Well, 8 divided by 2 is 4, which means I have 4 x squared minus 8s. I'm sorry, it's x squared minus 6, not 8. I'm getting the numbers confused. I have 4 x squared minus 6 underneath the square root. I know I have 4 because I took this 8 and I divided it by 2 to get 4, which means I have 4 of these. And then since we're grouping in 2 here, well, I have 4 of these expressions raised to the second power. I know this square root and all of these 2's are going to cancel, which means my final answer would be this guy in parentheses, x squared minus 6 to the fourth, because I have 4 of them. And since there's a negative out in front there, I'm going to keep my negative out in front here, and there's my answer. So what if we aren't working with the square root? Now that we're talking about nth roots, we have these greater roots we're going to try to find. So if we're looking at part C down here, now we're taking the 5th root. My index changed. So rather than thinking, okay, well, I need pairs, now we want things that are to the 5th power. So instead of dividing by 2 like we did up here, we're going to divide these guys by 5. And I don't know about you guys, but I don't know my 5th roots off the top of my head. So to see what the 5th root of 243 is, there's a few different things I could do. On your calculator, if you go to that math button and then you scroll down to number 5, the little x in front of our radical sign lets us take whatever root we want. So if I go back to my home screen and want to use that, I would hit 5 first because my index is 5. Go to my math button, scroll down to that where the x in the radical sign is, click enter, get that to show up, and they even put it in the index for me. Type in 243 to find out that that's just 3 to the 5th power. Say I'm not great with my calculator and I don't know where all those buttons are. I could kind of do a little bit of guessing and checking and say, okay, well, 2 to the 5th power is 32, so it's going to be bigger than that. 3 to the 5th power, 243. That's the number I want, so I know 3 is my number here that I'm looking for. So then breaking this down, I got my 5th root over here. Well, we just said 243 was 3 to the 5th power. 20 divided by 5 is 4, which means we have 4 a to the 5th powers. And then 25 divided by 5 is 5, which means we have 5 a to the 5th powers. And if we're kind of thinking in groups here, well, 3 to the 5th, that's 1 3 to the 5th, so I can pull a 3 out in front. I have 4 a to the 5th, so I can do a to the 4th because I have 4 of them. And then I have 5, this should be a b, I'm sorry. I have 5 b to the 5ths, so then I can pull out a b to the 5 right there, and I'm just kind of using that exponent right there to get what I need. And that would be our answer. So just like when we were up here, we were looking for groups of 2 because we knew it was a square root. Down here, we're just looking for groups of 5. 3 to the 5th, we have 4 a to the, we have 4 a's here, and we have 5 b's there. And that's just kind of how we're working with it. My wording might be a little weird, but again, essentially you're looking for groups of 5. So then to finish up this example here, we have part D. Again, we're back to the square root, but something I want to point out here is that we have a negative inside the square root. But that shouldn't scare us because we know that we're just going to have an I in our final answer. So breaking this down, I have -1. I'm going to bring that -1 in the front because I know I can do that. Times, well, 16 is just 4 squared. And then since it's a square root, I'm still working in groups of 2. So I have 4 divided by 2 is going to be 2x squared. So I'm going to break it down like I did at the very beginning rather than trying to group. And then 8 divided by 2 is 4, which means I have 4 y squareds. So again, I'm just taking the longer route and breaking this down, not trying to skip steps like I kind of did in the last example. Well, the square root of -1 is going to be I. We know that. Square root of 4 squared is just 4. Remember, we multiply everything out in front. I have square root of x squared is just x. Square root of x squared is just x. Square root of y squared is just y. Square root of y squared is just y. Square root of y squared is just y. Are you guys seeing the pattern? Okay, so then to combine like terms here, I don't like the I being out in front, so I'm going to flip-flop these guys to have 4i. Well, I have 2 x's, so I'll use that little exponent there. I have 4 y's, so I use that exponent there. And then something we have to remember with these that we haven't had to worry about in any of the other problems is that i's always travel in pairs. So whenever we have an I in our answer, even if they don't tell us, you have to have the plus or minus out in front because i's always travel in pairs. So hopefully you guys followed along with that okay. Again, feel free to look up different videos, going over different things. Email me if you have any questions on that. I know we kind of flew through that. But finding nth roots would be something good to Google there. We're going to go ahead and move on to our next example, which isn't quite as much. Just kind of adding a little part to this. Sometimes we're going to have to use absolute value. It's not going to happen often, but there's a particular case when we have to. And when you find an even root of an even power, so our index is even and the exponent inside the radical sign is even, and we're simplifying it like we just did in the last example, and our result is an odd power, we're going to take the absolute value of the result to ensure that the answer is non-negative, because we're working on finding our principal root here. So let's just take a look at an example, jump right into it. Hopefully that'll make a little bit more sense. Just to see that we're in the right scenario, we got a even root, even index, even power underneath. Since we're looking at the 4th root here, we're looking for groups of 4. Well, we have 4 y's, so the 4th root and this 4 and the exponent are just going to cancel each other out. to get y. And we know that technically, if there's no exponent there, it's just a 1. It's that invisible 1 we've talked about before. And since we started with an even root, an even power, and we resulted in an odd power, we got to throw the absolute value bars in front of this guy. I'm not going to be too picky on this. We don't see a ton of them, but technically this would be how you want to find your principal root. So let's try one that's a little bit harder. Over here for part B, our root or our index is 6, so that's even. And we have a power over here. Our exponent is 18, also even, so we're set up for this situation. So let's just go ahead and solve it like we did the last example. I don't know my 6th roots by off the top of my head, so I'm going to go ahead and get my calculator back out, and I'm just going to use that guess and check method and do 2 to the 6th is 64. Ooh, imagine that right away. So I'm going to break this down again. I have the 6th root. I have 2 to the 6th power. Okay, well 18 divided by 6 is 3. Right, I'm working in groups of 6 now, so 18 divided by 6 is 3. So I have x squared minus 3 to the 6th power. I have x squared minus 3 to the 6th power. I have x squared minus 3 to the 6th power. I have 3 of them because 18 divided by 6 is 3. And I use the 6th power here because that's what I have out in front, because I know that's what's going to cancel. So then simplifying this, the 6th root of 2 to the 6 is just going to be 2. And then the 6th root of this, x squared minus 3 to the 6, is just going to be x squared minus 3. And we're going to follow that pattern here 2 more times. So then simplifying this, I have 3 of those, right? So I'm just going to have 2 x squared minus 3 cubed because I have 3 of them. And then looking back to our little scenario up here, we fit this part. We resulted in an odd power right here because 3 is odd. So this would be another scenario where I'd throw those absolute value bars. You can always just ignore the number out in front and just kind of use your expression here. So like I said, we're not going to use a ton of those. On your homework, I believe there's only one, and it's going to look very similar to this right here. There's only one. I'm not going to be too picky about it, but I just wanted to show you guys in case you ever saw like an ACT question with it on there. And we're almost done. I know this was a little bit longer of a video, but it was good review. The last thing we're going to talk about is approximating radicals. You're going to like this part because we get to use our calculator and we get to round. There's no simplifying, just being able to type it in. Again, approximations is just rounding. A lot of times with square roots, we have irrational numbers, so we'll just round, especially in word problems. So our last example here is the surface area of a sphere can be determined by the volume of a sphere using this formula, where V is volume, and they want us to find the surface area when the volume is 200 cubic inches. So I'm going to plug this 200 in for V right here to get that S equals 3 cubed, or the cubed root of 36 pi times 200 squared. And right away, seeing that pi underneath that cubed root, I'm like, oh, nope, I don't want to do that. So I'm going to bust out my calculator, and I'm going to use my math button. I see that the cubed root is already built in there, so I'm going to scroll down to the 4 to get that cubed root to pop up, and then I'm just going to type in what I have. I have 36 times pi times 200 squared to get that this is approximately 165 cubic inches, or inches cubed. And that's all I want when I say approximate. If I'm ever giving you a word problem, you can just round. And if I don't tell you what to round to, you can just round to the nearest whole number. So then that wraps up our section here. So here is your homework assignment. I will have the picture of the textbook page posted onto Classroom, as well as it's the textbook that you guys have at home too. Let me know if you have any questions.